Thank you all for joining us today. It's my pleasure to introduce Greg Mayer. Greg Mayer's from Georgia Institute of Technology, and he's presenting Empowering the Future, how the distance math program offers undergraduate courses to advanced high school students in Georgia. Greg, I think your microphone's muted.
Oh, there, now you can hear me. Okay, great. Phew. These things are easier to solve when you're not giving a presentation for some reason. I don't know why. But yeah, thank you, Gavin, and thank you everybody for coming. When I was putting these slides together, I was not sure what to expect. I've never presented at a conference like this, but I was envisioning that there'd be some people who are attending who are interested in teaching online and perhaps teaching to high school students. So I think I've got the chat set up. I'll if you have any questions or you want to share some experiences, go ahead and type things in the chat. It is a conference after all, so I'd love to sort of meet people and who knows, find some people to work with down the road. That'd be great. But for this talk, I'll go through how the distance math program works. It's, as far as I know, not like anything I've seen before. I don't get to talk to a lot of people who teach online and teach high school students. So that's another reason I'm interested in hearing what your experiences might be. But I'll share what this program is, how it works, technologies we use. I'll talk about the differential equations course that we have in it, and along the way, some of the benefits and challenges that we have found by the program. All right. So the distance math program is something offered at Georgia Tech that offers undergraduate courses to Georgia high school students through a structure called dual enrollment. They call it dual enrollment because students can be enrolled in two places at the same time, at their high school and at a nearby college or another college. And in fact, they can enroll in more than just one college, but that's a whole nother thing. And at the same time, they're receiving credit from their high school and from that college. I'm not a dual enrollment expert. In some states, it's called other things like concurrent enrollment. But a copy of the slides, by the way, there's a QR code. I'll have the same QR code at the end. If you want a copy of the slides, then they're on my website. You can get them there. But yeah, if you want to drill down on all the procedures with dual enrollment, it's there. On the Georgia Georgia DOE website. Our program has, right now, it has 4 courses. We're looking at adding a new course in the fall, but right now we have linear algebra in the fall, multivariable calculus in the spring. Most of the students on our program are high school seniors, so most of them will take this sequence that are enrolled as a senior. Most students who complete linear algebra go on to take multivariable calculus. There's a few who decide, oh, it's not for me. It's not going to apply for my major, so they take other things in the spring. But we do have students who are juniors in this program. And so in their senior year, they've exhausted their math options. They're still interested in taking more math. We offer applied combinatorics and then differential equations. We chose these 4 courses because these are core courses that meet a lot of degree requirements. So students, depending on whether they're engineering, CS, or whatever, a lot of them need to take most of these courses, at least the linear algebra and some kind of multivariable. This program wouldn't exist if we didn't work with other units on campus. School of Math handles the assigning instructors, teaching assistants, training them to be able to teach, give them some support. I'm the director of online learning. I don't completely know what that means, to be honest, but I know that I support the teaching assistants and instructors who are part of this project. Professional education, whenever we're setting up a new course, changing which technologies we use, we work with them to figure out best practices, set up our courses. They have an instructional design team that helps us in various ways. They also help with exams. I'll talk about that in a minute. And then admissions handles the application enrollment processes. To apply, like basically you have to be a Georgia Tech, you have to be a Georgia resident. We do get the odd question about out-of-state students, and we've thought about that, but we have a large demand just within Georgia, so we haven't really considered that yet. But to apply, a student needs to have a score of 4 or 5 in AP Calculus BC. So we're talking already about a very strong population, right? They've managed to not just fast track to finish AP Calculus BC in their junior year or earlier, they've also done very well in those courses. So this program, I think, the distance math program is successful for many reasons, one of them being that these are strong students. And so the amount of support that we have to give to the many students that enroll is not as much as you would see if we open the doors a little wider. But the Georgia Tech admissions website, if you want to get into the details, has more information on how all of that, their processes work. In terms of impact, and this is why I say to people, it's an honor to be a part of this program. Just half of the students who take this program, who get in, go on to enroll to be Georgia Tech students. And admissions tells us that just among the in-state students that they admit into an undergraduate program, around 1 out of 6 of them have completed our courses. And that still blows my mind after working in this program for more than 10 years, that this is not something we thought would happen when the program, I wasn't around when the program was set up. I don't think this is something that we envisioned as happening, that many students would be coming to Tech having already completed multivariable calculus. And it's on their transcript and they have credit for it. So they're in their first year taking differential equations, combinatorics, intro to proofs, and so on. It's amazing that it is where it is now. It started in 2005. In 2005, I was up in Canada working on my PhD, and this program started with about, I think, 6 high schools, around 30 high school students. Video teleconferencing technologies were obviously very different. They were mailing exams back and forth with UPS in 2005. And I started at Tech around 2012, and when the program was about 300 students. It's now 760 in this program. The year 2 program really started around 2015 with about 11 students. And for a few years, the enrollment was pretty low. So if you're thinking about setting something up at your institution, it can take a while for the thing to get off the ground. But now we're a little bit over 120 students taking differential equations right now. Yeah, and it continues to grow every year. And we don't advertise the program. It just, word of mouth is more than sufficient. All our courses are asynchronous. We have pre-recorded lectures, but we still have some live studio sessions because some students enjoy having live Q&A. We tried to be professional and make pretty slides with LaTeX. I did a lot of recordings with Camtasia. Our live sessions use OneNote. The teaching assistants annotate things, annotate worksheets that we've made in LaTeX. This is the first page of one of our exams, happens to be linear algebra. All our exams are in-person proctored. Each high school has a designated proctor who prints the exams, proctors it, and sends it back. We use something called Gradescope. I'm not sure if you're familiar with Gradescope, but it has some built-in AI tools that kind of been well, it's been a game changer for us. It means For a true-false question like this, it can group all of the students who wrote true into one group, and you have to check to see if it grouped it correctly. But once it is, you just have to grade one sample from that group. And so it speeds up grading tremendously. Even for fill in the blank questions where they have to write a number, it groups them fairly well. Put all the students who wrote 2 in the same group, all the students who wrote 0 in another group, all the students who left it blank in another group, and so on. And you just have to check to make sure it grouped it correctly, which it does a pretty good job. And so it speeds things up. Here's how exams really work. The poor instructor has to make 3 or 4, 5, whatever, how many versions of each exam. They send it to professional education. Professional education uploads it to a shared folder among all the facilitators. The facilitators print those exams, proctor the exams, scan the exams, scan them, send them back to professional education, who puts them into Gradescope. Those steps takes about a week, because inevitably there'll be pages that are upside down, missing, scan is too light, whatever, there's a billion things that can go wrong. We grade them. That takes like 2 days. In Gradescope, it's really fast, but the whole thing takes a while. They're all great textbooks, but the thing is, we want to use the same textbooks at the on-campus section. So we want to say to our high school students that these are very much aligned with the courses that are taught just in face-to-face on campus. But state policy is that students can't be expected to pay for anything. So who pays for the textbooks? So things are getting expensive. And you have to distribute textbook codes to 700 students in the fall who don't have email accounts yet. Do they check email? Is the email going to go to their spam? And it's a bit of a mess. So we're working towards OER, but it's not something I want to do overnight because, like I say, there's a lot of students who go on to tech. We couldn't do this without a huge team of assistants. We hire many undergraduate and graduate students to make things work. Head TAs, lecture assistants, graders, curriculum developers. There's a huge team. The curriculum developers is kind of a newer thing when we realized that there was just a lot of work that had to be done to keep things current, keep the worksheets and the lecture slides and everything going in the direction we want to go, especially in moving to OER. In year 1, we have one head TA who grades office hours all the way down to develop curriculum. TAs do all of that except some of the admin stuff. We hire lecture assistants, graders who just grade, and so on. It's a big team. Differential equations, it's a smaller course, right? It's only about 120 students. So if you can get by, you can get by with just a TA and a grader. But moving quickly, some of our challenges are here. I don't want to list all of them, but publisher textbooks and online homework systems seem to emphasize long computational hand calculations, where students are required to write out some long process. And as anybody who's been teaching for a little bit knows, you don't necessarily have to understand what you're doing to complete those multi-step processes. There are some true false, more conceptual questions in the textbooks that we've chosen. But getting us there to have those types of questions takes a bit of work. We're trying to use WebWork at Georgia Tech. It's taking a while to get it to work the way we want it to, but we're off the ground. We're using it in many of our courses now. Distributing textbooks, the time it takes to make all those exam versions. We have many assistants, though, who are building things in WebWork, building OER, open educational resources across many different platforms, and AI. I can talk a little bit about how we're using AI to speed things up. And, of course, since we have all this curriculum, we can use it in other projects on campus. We have been sharing our slides and worksheets with other instructors at Georgia Tech, and used it to do other things. So we have a 4-part linear algebra series on edX, a DEI initiative that's been moving along a little faster because of all of this. I promised I'd talk a little bit about differential equations. So this is a course, differential equations, that's offered every spring. It has when I taught this course face-to-face in 2019, they recorded my lectures. And so I just had to go through and chop them up into little segments and give them little titles and descriptions like I did here for every little video that I made. I think there's probably about 100 videos. And, you know, it's a standard course at Georgia Tech. It's got a linear algebra focus. There's a linear algebra prerequisite. So we go into linear systems and, you know, we don't have time for a series, but those are the topics we cover. I don't know how many people are here. I was going to ask, we have a project as part of this this course because they're advanced high school students, and I think they're looking for something a little bit more challenging than just, you know, exams and homework. And I think, I don't know how many people, not many. Okay, that's okay. I'd love to hear what experiences people have with projects. But our projects in this differential equations for high school students is modeled off the Scudem challenge, which, if you're not familiar with that, it's an annual mathematical challenge with open-ended problems, and students have a few weeks to come up with a solution. They submit a YouTube video that gets judged by many, many people from all over the world. And I looked at that challenge a few years ago and decided to create a project that was kind of like that, where students have to come up with a solution. I say they has to be numerical so that it ties better into the course objectives. Students have to work in groups. I've set it up so it has to be an essay. I'm not sure. I could just do it as a video, but and I give them a list of recommended topics. A lot of them are based on the Simeode website, which has many great project ideas. They submit a final project at the end of the semester, and there's, as part of it, to help quality control, there's a mini conference. And I say quality control because if you know you have to share your project with your peers, you'll produce something that's not a blank piece of paper, right? It'll be a little bit better, and so it helps students stay on track on completing their project. I even have the comments they write as a graded activity, so students have to write something positive, suggest some revisions, and students have to reply to that. So it creates a bit of a productive discussion that I think is easy to grade. But then I have a team of assistants, so I mean, I don't have to grade it, so I don't know if I should say that. After doing this a few times, I kept noticing students would make the same mistakes. Like, they would give me 10 graphs that are basically the same thing with a slight parameter change, or they would give me a graph but not explain what it is. They wouldn't label their axes and so on. And so over a couple semesters, I just kept tweaking the rubric and the instructions, and now it's many pages long. If you want to see what I did, you can use your device and scan it. I'll have this QR code at the end as well. But I feel like I've, in having a project, introduced kind of a technical writing component to my course, which is probably not a bad thing, given that I think the students who are there who are taking this differential equations are going to have to do some writing down the road anyways in their future careers or grad school or both. I think I still got plenty of time. I just zipped through my slides. So thank you everybody for coming. I'd be happy to answer any questions or share some experiences with the people that are here. Anybody have some questions or?
I've got one question, then I'm gonna have to run.
Cool.
Okay, I'm sorry if I missed this somewhere. I had to step out for a minute. But those courses I saw where you have linear algebra and then multivariable calculus,
Yeah.
and then you had another more discrete type path. But what I was going to ask is this linear algebra course, it's is it more like a college level linear algebra, or is it more of an algebra level linear algebra? Because I know that linear, depending on the I guess the textbook or the teacher, it can be very abstract at times.
Yeah, linear algebra is funny that way, right? Because you can have it at many different levels, all the way up in grad school level, where it's like preparing students for a comp exam or something, right?
Yeah.
We don't touch abstract vector spaces. So we do go into things like orthogonality and SVD. So it is we work everything in Rn, if that helps. But it's a very applied, there's some applications in there, and it's
Yeah.
which level?
Yeah. I was thinking that for a high school student, it would probably have to be more application based because their mind probably hasn't got the maturity, the mathematical maturity yet. But I appreciate you letting me know. I've got to run though, but thank you.
Yeah.
You had mentioned the possibility of introducing more courses, I think.
Yeah.
Do you have an idea of what courses you would want to teach in the future?
Well, yeah, I could say a few things. We are on track to set up a new course in the fall. Not we're pretty confident it's going to happen. It'll be pre-calculus, so our math 1113, and it'll probably have a very small enrollment with one high school to start and build it up over the years. We used to offer number theory, and it was a lot of fun. I think it was a very interesting course, and everything was set up and it was running well. But the problem with number theory is that it's not a required course for many majors, so the enrollment was never going to be large. And if you want things to be, oh, thanks, Tom. Yeah, if you want enrollment to be such that it's the program pays for itself, you've got to come up with something that's popular. And we did try. There was an effort to get, what was it, genetics, or was it organic chemistry? It was a chemistry course. But because they weren't required courses for many majors, the enrollment never was sustainable. You know, these programs have a certain cost to keep them running. So, but you know, everybody has to take some linear algebra at Georgia Tech. Everybody has to take multivariable calculus. So those are popular enough that the courses work, the numbers work.
Gotcha.
Oh, I'm just curious if you like require the students to take that exact sequence, because like obviously you can like take combinatorics like without calculus theoretically and linear algebra without the other. So or if they
Yeah,
can so choose.
yeah, there's a bit of choice. We've admitted students who have completed, for example, a linear algebra course at another institution to enroll in combinatorics. Our combinatorics does have a linear algebra prerequisite. So as long as students have taken linear algebra somewhere, that's fine. But they don't need to take multivariable calculus to take, you know, they don't have to take multi to take applied combinatorics, and they don't need multi for differential equations either. So they could, in theory, skip it. Yeah.
And I'm assuming they're not proof-based at this point, right? Like they're not like a proof-based course.
Yeah, there's that's right. I mean, there is a intro to proofs course at Georgia Tech, but it's not a prerequisite for any of these courses. So even when the courses are taught normally on campus, there's a little bit of proof in 3012 in the combinatorics course, but
Mhm.
it's not a requirement. So yeah, it's that would change, that would make things harder to teach. Yeah.
Yeah, like I think it'd be really hard to teach like an intro to proofs class like virtually. That's kind of why I was asking.
Yeah, I mean, I think there's a need for it. There's many majors who need to take an intro to proofs course. But I think that kind of thing does require a lot of writing, and that makes it harder to grade. But it's also, I don't know, I mean, there's something about in-person communication that is, I don't know, maybe a little more required in intro to proofs. I don't know. That's a course I haven't taught, so.
Agree with that, I'd say. But I just like know that sometimes they will teach linear out like proof-based linear algebra courses. So I'm just curious.
That's true. Yeah, there are
Yeah.
some institutions that do have a more proof-based intro linear algebra.
Right.
Ours is more just computational and application. So yeah.
Yeah, because it's sort of general, I guess, like whether they go into like comp sci engineering or pure math. So, like,
True.
yeah.
True. Yeah, yeah. Engineering wouldn't need the proofs as much. So
Yeah. So,
yeah. Yeah, I mean, we do have a second course in linear algebra that's more proof-based. That's at
hmm.
higher levels for those students who need it, our math majors, for example.
But I
Um,
guess they can't take that one with people in high school. Like, it has
no,
to be.
yeah, it's a 3000 level, and then because yeah, I mean, it could be a course we could offer down the road. I could see us offering other courses. I know I don't know of many other institutions offering these types of online courses. I know CTY, Center for Talented Youth, does. They have a kind of a proofs course. So how they do it, I'm not quite sure. But yeah, that'd be interesting.